solve using the square root property. If w squared equals d, then w equals plus or minus the square root of d. So when an equation of degree 2 is set equal to 0 and b equals 0, meaning ax squared plus bx plus c, if b is equal to 0, you can obtain, or something squared on one side, okay, then equals a number on the other. You can use the square root property. So when I say b equals 0, I'm talking about the bx in ax squared plus bx plus c. All right? So where does this come from? How do we get plus or minus? This is something that really bothers me because almost every video out there tells you to take the square root of both sides, which you do not do when applying or using this property. And don't forget the plus or minus is what they tell you, but they don't tell you where it comes from. Okay? Well, that changes right here, right now, because we're going to walk through where it comes from, and we're going to discuss how to apply the square root property to solve an equation properly. Okay? Just make sure you understand. Do not take the square root of both sides when using the square root property to solve. Yes, I know that was very blatant, okay? But it bugs me to no end, even when I ask other math teachers that I know personally, hey, why do you, I don't know, it's just what I do. No, you're supposed to know, you're the teacher, okay? So we're going to talk about where it comes from, and I'm going to take the square root of both sides, but when you apply a property, the whole reason the property is there is because somebody's already done the work for you. But we're going to go through the work here to show it. So let's discuss the steps involved to go from if to then for the square root property, okay? This will also show us where the plus or minus comes from and why we shouldn't forget it. To go from the if to the then. How do we get there? Okay? If w squared equals d, then w equals plus or minus the square root of d. So let's start with the if. To begin, let's start with if. W squared equals d. Take the square root of both sides. This is the work involved in proving the property, not using the property. You with me? There's a difference. If I prove something, I've got to go through the steps to prove it. If I use it, I go from if to then without anything in between. So my point is, when you show taking the square root of both sides, you're showing something between the if and the then, and you're not trusting it. It's already been proven. Somebody really smart did it way long time ago. All right, so we're going to take the square root of both sides, but this is the proof of it. This is the steps. The only next correct step, if you show the square root of both sides, is the absolute value of w. Anything else is wrong, period. If I do it, I'm wrong, okay? And I know it's not proper to say somebody's wrong. It's wrong, okay? It's wrong. If somebody doesn't put absolute value of w, it's wrong, okay? These are the steps involved. That's why I changed the color to green here, okay? Then, if the absolute value equals something, then you remove the absolute value, w equals absolute square root of d, or w equals negative square root of d, and that comes from, really, the other side is this, and then you divide both sides by -1 to get back to here, okay? So, definition-wise, that's where it is, but that's where the plus or minus comes from. W equals the positive or the negative. It comes from the fact that you have the absolute value of w equals something. That's where it comes from, okay? So then we finally get back to the then. W equals plus or minus the square root of d. When you have an if-then statement, an axiom, a property in math, you go directly from here to here, and you skip all the middle stuff. So if you take the square root of both sides when you're using this property, it's actually not following directions, and I will count it wrong. And this is why. Okay? Call me crazy, call me whatever you want to, but I'm not crazy. This is very logical. Logic is hard to come by these days, but that's very logical. That's where this comes from. That's what it is. When you say if something, then something, and it's been proven in math, okay, then you go from the if to the then. You don't show the steps in between. So to take the square root of both sides is showing the steps in between. If you can't tell I'm fired up, okay? So once you have a property in math, I've just said this like 7 times already, you do not show all the steps required to move from if to then. Someone else has already done that work, okay? It wouldn't be a property if they didn't. So you simply go from if to then without showing all the in-between steps. These are your in-between steps. You don't show them, okay? You don't show them. So that is why you do not take the square root of both sides when applying the square root property, Okay? So now, let's solve using the square root property. Deep breath, right? So x squared equals 36. All right? So I'm going to take a peek here and see if I did some stuff here with this or if okay, good. All right, so x squared equals 36. So then, does this fit the bill? Yes, it's w squared equals d. So what do I do to apply the square root property? I simply drop the squared. X equals, I put plus or minus, and I do square root of this other side. And it took my minus sign away. So x equals plus or minus the square root of 36. But wait a minute. X equals plus or minus the square root of 36 is 6. And there is your final answer. Okay, that is applying the square root property. And if you told me, hey, Mr. Guest, I skipped that step and I know what the square root of 36 is and I just wrote 6 down, I would believe you. Okay, I would believe you. But if you did this, my pen is going to tear your paper apart. Okay, because that's not what you do. It may have been what you were taught, but that's not using a property. When you use a property, you go from if to then. You don't show what's in between. Okay, and maybe you're just remembering when your teacher showed you what I just showed you. Okay, I haven't been sitting in the classroom with you when you took it in algebra in high school, but I got a lot of students that say, take the square root of both sides. Nope, not what you do. Not when you're using the property. If you want to show all the steps, that's fine, but then you better show the absolute value step or it's wrong. Okay, so c squared equals 13. So again, I say c equals plus or minus the square root of this other side, 13. And guess what? I cannot simplify the square root of 13. So that one is actually done. I didn't need a whole screen for that. But anyway, there's a whole screen for that one. All right. So let me erase this too. All right. So let's look at the next one. X squared equals negative 4. So then here, something squared equals a number. So x equals plus or minus the square root of negative 4. Right. Now with real numbers, we'd say this is not a real number. So if you're in a class and you haven't talked about the complex numbers or the imaginary unit or anything like that, then you would say, hey, that's not a real number, can't do it. But if you have talked about it, then you would say, oh, wait a minute, I know what the complex numbers are. So then this is going to be x equals plus or minus, and the negative part is I, and the 4 comes out as 2, okay? So the square root of 4 is 2, and the square root of a negative is I, all right? So that's my final answer, plus or minus 2I, okay? So 5m squared equals 45. Do I have something squared equals a number? This is where you got to be careful. The 5 is not squared, so you need to get rid of that coefficient first. So I need to divide both sides by 5. And if I do that, m squared equals 9. So once I do that, now I'm ready to apply the square root property because now I have something squared equals a number. M equals plus or minus the square root of 9, which again, you could skip that part. M equals plus or minus 3. You could go straight to 3 there is what I'm saying. But don't show the square root of both sides. I can't iterate that enough or reiterate that enough. I can't say it enough. Say it until I'm blue in the face, my voice goes away. All right? You don't take the square root of both sides when you're applying this property. It's not proper. It's not proper in any property in math to show a step in between. So then let's look at the next one here. Something squared equals a number, so we drop the squared. It's just the something, x minus 4 equals plus or minus the square root of negative 7. And here we have that negative again. So again, if you're doing real numbers, you'd say, oh, not a real number, go on. But I'm going to go ahead and show the imaginary part that way just in case it's in your class. All right? Just in case it happens in your class, then, and I've taught algebra classes that did both. This came before complex numbers and came after complex numbers. So either way, but I want you to see it just in case. So this is x minus 4 equals plus or minus. The negative becomes I, and the square root of 7, you can't simplify that. And typically we put the square root of 7 after the I, even though a plus or minus, bi. But that's because you don't want to confuse it. If you did this, that's okay because the square root doesn't go over, but some of you will do that and the I is not under the radical, and some of y'all are not careful about that anyway, and you need to be, all right? What is over, whatever the root is over, the radical is over is what's under, and if it's not over it, it's not under it, okay? So, not part of it. So here, I'm going to add 4 to both sides, and you could do 2 equations here, but I mean x equals 4 plus or minus I square root of 7, and that's going to be sufficient. You can't do anything with that because of that I. You can't combine those two terms. So 4 plus or minus I square root of 7. Now, just so you know, x is 4 plus I square root of 7 or x is what? 4 minus I square root of 7. So that's an alternate way to write the answer. I do want to point that out, that the plus or minus literally means 4 plus that and 4 minus that. And if that was just 7, we could say, 4 plus 7 is 11. 4 minus 7 is negative 3, but it's got an I on it and it's got a radical. So we can't just combine it. All right? We can't just combine it. So then here, 2d plus 5 in parentheses squared minus 169 equals 0. It's not something squared equals a number, but what I'm going to do first is add 169 to both sides. Okay, that's going to cancel over there and give me 2d plus 5 squared equals 169. Now it's set up in the form to use the square root property. Now that's the best move here. That's the most efficient move. The way we do that is we drop the squared, so 2d plus 5 equals plus or minus the square root of the other side, plus or minus the square root of 169. What is the square root of 169? That's right, it's 13. That's a little bit beyond your times tables probably, or at least when I was in school, y'all probably do like up to 25 by 25 now or something, but back when I was in school, we did these flashcards and it was 12 by 12. That's as far as we went. So if somebody said multiply by 13, we just stared at them. All right. So 2d plus 5 equals plus or minus 13. So because this is a number like 5 and 2, then guess what? I'm going to go ahead. You can do this different ways. Actually, let's go ahead and solve it. I'll do this two different ways. I'll do one way in orange and one way in purple. So at this point, let me write this down in blue over here. So you can do it this way, or there's another way you can do this. So what I'm going to do in orange here is solve it first. I'm going to say this is minus 5 and minus 5. So 2d, you just can't put these together because that's got a plus or minus in front of the 13, so you got to do this. And then divide both sides by 2. So you get d equals negative 5 plus or minus 13 over 2. But you can't leave it like that because you can combine those numerators if you knew. So you'd say d equals negative 5 plus 13 over 2, or d equals what? Negative 5 minus 13 over 2. So this is going to be a positive 8 over 2, which is 4. And this one's going to be a negative 18 over 2, which is negative 9, right? So 4 and negative 9. So d equals 4 and negative 9 are your two answers there. D equals 4 and negative 9. So what that also tells me is if I were to foil this out, write it twice and foil it, and then move the 169 over, get it equal to 0 and factor it, it's going to be factorable. Okay, so but that's okay. This is still the quickest way to solve it, or most efficient way to solve it. So I promise you another way to work it. Over here in purple, you could have said, wait a minute, I don't want to do this where I have this business right here because that confuses me. So I wanted to say 2d plus 5 equals 13, or 2d plus 5 equals what? Negative 13. Okay? So then you just solve each one of them. And some of you don't mind doing the extra steps on this side because it's less confusing. So still get d equals 4 here, and then I got to do the same steps again. I just get different numbers along the way, different values. So I still get 4 and negative 9. All right. So however you want to do that, whether you move the 5 over, make it negative, and then have negative 5 plus or minus 13, you just have to remember to go simplify that at the end. Or 2d plus 5 is 13, or 2d plus 5 is negative 13. Either way you want to do that. You can either do that the orange way or the purple way here. It doesn't matter. Preference is yours. Now, if you have a teacher that says you better do it this way, then if they're your teacher, do what they say because you're in their class. So then here, 3x minus 7 in parentheses squared plus 25 equals 0. I'm going to subtract 25 from both sides. That cancels. I get 3x minus 7 in parentheses squared equals negative 25. And then I'm ready to apply the square root property because I got something squared equals a number. Let me go ahead and apply it in this blue here. So it's going to be 3x minus 7 equals plus or minus the square root of negative 25. So 3x minus 7 equals plus or minus, the negative part is I, and the square root of 25 is 5. So plus or minus 5i. Now, that has an I on it, so when you bring the 7 over, you can't put those together anyway. So it's common practice just to leave the plus or minus, just to add 7 to both sides. So I get 3x equals 7 plus or minus 5. And we typically write real part first, the 7, and then the 5i second, and it's plus or minus 5i. Then we divide both sides by 3. So then x equals 7 plus or minus 5i over 3, and I don't think I said this on one earlier. I need to look. I may flip back while we're still on here. I'm going to come up here. This answer's fine. I would accept this answer unless my directions say put your final answer in. Put your final answer in. Oh, I didn't mean to do that. Put your final answer in standard form, the standard form of a complex number. Okay, a plus or minus bi. If I did that, you would need to do this. Oh, hang on. Sorry. Didn't change it back to the marker. X equals 7/3 plus or minus 5/3 I. There's a plus or minus bi or plus bi. So that's your final answer in standard form. This is another version of it. So either way, just make sure you know if your software package or if your teacher, instructor, your professor says, "Hey, put this in complex number in standard form," then you better do that. You better put it a plus bi. That's this right here. Okay. So just make sure you know that. So let's go back and see, did I do that on another one? Complex number. And I did that there. Okay, I guess that's all of them. Yeah, okay. All right, well, I hope that helps you out with the square root property. Again, I'm passionate about this one a lot.